I'm going to talk to you today about my Google Summer of Code project this summer, which was wlroots frame scheduling. So this summer, I didn't mean to leave that in. This summer, I did useful work on software, and we're going to see everything that I did and everything that I didn't do. And if you are a user, by which I mean a compositor developer, not a Sway user, for example, pay close attention because there are breaking changes. I'm sorry. So we're going to start out with the situation we find ourselves in, which is the same situation as any graphical application is going to be in, where we have a couple of problems to sort of reconcile. Firstly, the display is usually going to refresh at intervals, say 60 Hertz, and we're not able to influence that. It does it. The real world does not refresh at 60 Hertz. Users can move their mouse, they can press keys, all kinds of things happen, and the users will be angry at you if these mouse movements take too long to get to the screen because they want it to happen in good time. And finally, not finally technically, but rendering, we don't know how long it's going to take before we do it. So that's another kind of spanner in the works. And the real finally, which is not relevant to every graphical app, but it is relevant to compositors. Clients also exist, and we have to get them to render. We tell them to render, and when they finish, we use the things that they give us to put them on the screen. And they're evil. They like to do things like multiple frames per frame, or complaining. They like to claim they're going to render a frame and then not. You can't really trust them. So you've got to take all of these edge cases into account if you're touching this kind of stuff, which is fun. So the state of things at the moment is that most wlroots compositors use this scheme. I think Sway doesn't because it's special, has enough users for someone to care and like make a special case for Sway. But it's encouraged by the API of wlroots that you would have something that looks like this. And specifically, what we have here is that on a refresh from the display, the compositor becomes aware of that and immediately does both things, telling the client to start their rendering and starting its own rendering. And they happen at the same time. And that's not good. We don't want to tell the clients to start rendering and then immediately start rendering ourselves, because that means that the client is guaranteed to not have finished rendering by the time we start. It's not going to happen. And as we can see here, a good way of reasoning about this is that client render 1 is finished before compositor render 2, and compositor render 1 would ideally have picked that frame up, but it can't because it started too early. So ideally it looks like this. And what we want to happen is that our compositor rendering finishes just in time for the display to scan out. And this is true, like I said, of a lot of graphical apps. You'll have some kind of deadline, and you want to finish rendering as close as possible to that deadline, so that you're not sitting around with a frame that you've rendered, unable to do anything until the display refreshes. And here, I didn't change the client render times. They can do what they like, but usually they look something like that. And now we can see that client render 0 is going to finish before compositor render 0, which means that client frame will make it into display refresh 1. And that means you lose 16 milliseconds of latency on a 60 Hertz display because you're displaying those client renders 1 frame earlier than you otherwise would have. So I came into GSoC and I thought, okay, this will be fine. I know what I'm doing. I'm a smart person. And I forgot to click through all of my lines first. So if I backtrack a little bit, then we'll see the compositor render is also able to pick up user inputs. So those 3 far on the left are going to make it into compositor render 0 because it starts after they happen. And they'll make it also into display refresh 1 instead of 2. And like I say, users love to have low latency. They love to move the mouse and then it happens immediately and everything looks smooth. I don't remember screwing up my animations on this one. I checked it many times. But I went into this, I thought, I know what I'm doing, it'll be fine. And I tried to I tried to sort of redo wlroots' frame scheduling infrastructure. You can see a screenshot from GitLab right here of my first patch to wlroots on this topic. I sort of patched up a few things, put a call to this in there, redid how that works, and tried to add the delay between the present notification and the start of rendering. I thought I had it all covered. I absolutely didn't. Kenny came in and said, better worded than that, but he said, that's not it. Things are like that for a reason. Please don't make them break. You are supposed to, in GSoC, learn about the project that you're going to work on just before the summer. But just before the summer is exams. I'm not sure how they missed that one. So I kind of rolled in and became the reviewer's problem. But thank you to all reviewers who are patient and help the authors learn, because this would have been awkward otherwise. So we know that we want to finish rendering as close to the deadline as possible. And if we go over, that's tragic, because then you have to wait for the next refresh to come around, which is even later. And we don't know how long it's going to take to render, but we can guess. So I think strategies that people have already implemented this I think Kwin uses a window of maybe 15 previous frames, and they'll say, so some of them took 3 milliseconds, then one after took 4, so the next one is probably not going to take more than 5. And then they can use that guess with a bit of tolerance built in, because you might guess wrong, to time the start of the render correctly. And in wlroots, we didn't have any way of measuring how long a render pass took before, in fact, at all, before I came along. So that was the first task after the failed flailing around at the beginning, is for me to add a way to measure the duration of render passes, the time from submitting them to when they become available for display. So now, if you're a wlroots user and you want to know how long your frames are taking, you can use this nice interface, which is implemented for Glass 2. Not Pixman, because the answer is going to be like 3 seconds anyway. And Vulkan, I have the implementation on my disk. I need to submit it. I'm sorry. If you're using Vulkan, then you're strange anyway. I think that backend's experimental. So we're back to here. Now we have a timer to learn from. And we want to make good guesses as to how long a frame will take based on the duration of the previous ones. So I thought, being the idiot that I am, it would be cool if we could see the frame time behavior. So I thought I'd develop a visual tool that drew a nice little graph of the frame times, and you can see that when you open Firefox, it went up by 4 milliseconds, so you need to build in tolerance for that. What a great idea. And then people can adjust the parameters in the other work such that we get the tightest possible deadline squishing. But alas, the way I thought would be a good idea to implement this was inspired by seeing GPU Viz, which Simon thankfully recommended to me. You don't need to be able to see much of the detail in this picture, but I do want you to gather that it's clearly a pretty extensive program. It's got 7 blue arrows. How many more blue arrows do you want? And you can see all kinds of data in GPU Viz. You can filter, scrub, you can do all sorts of things. So I thought, if I'm trying to visualize things, it would be a good idea to use a pre-existing tool rather than to build the whole thing from the bottom up. So I thought, well, let's try to inject events, custom events, into this timeline. And it is possible to do. But you have to be a wizard, apparently. I wrote a library to extract over the kernel interface, because GPU Viz extracts its events from Linux. And Linux is able to maintain a timeline of sort of fences being signaled and whatnot. It has this user events data file that you can open and do some OCTLs on. So I wrote a library to abstract over that, make it nicer for people to use. But it didn't go well. I had all kinds of problems with this. Events just kind of wouldn't come through sometimes. Not sure why. It didn't work. I ran out of time. No more frame time tool for us, which is sad. But you can still use the library if you want. If you're doing some injecting of these events, feel free to download it and use it. So with the tracing and the visualization having failed, back onto the main track, I was going to have another stab at redoing the scheduling infrastructure in wlroots to make it not encourage the bad timeline that we saw at the beginning. But that was tricky. The old interface, which is still in master because we're nearly there, I'm sorry, is primarily based around this function, schedule frame. And by calling this function, you're asking, please can a frame event happen at some point? So it's like saying, if the render loop is asleep, wake it up. But otherwise, it's fine. We just carry on. And that turned out to be quite hard to reason about, which was a shame. But after many weeks of thinking and going to bed and thinking while I was in bed and then getting back out of bed and trying to implement that and then thinking I was stupid while I was in bed because it didn't work, I finally came up with something, which is the new frame scheduler interface. And there is currently an open merge request and it's been through a few rounds of review and it's hopefully going to get through soon. But what this does is it gets rid of the old WLR output schedule frame, which is tied into WLR output, and outputs are necessarily keeping track of things that are the frame scheduler's concern. So with the new interface, things can be taken out of WLR output to leave it more tidy. And also, we now have different implementations of the interface based on what use case you're aiming for. So this was already, all these use cases were already supported before, but it was getting kind of messy because, for example, on DRM or on Wayland with WP presentation, you can receive presentation events from the display and then use those to drive your render loop. But if you don't have that Wayland extension, then you have to use wlsurface.frame, and that has different semantics. And then if you're on headless, you have to just invent the whole thing yourself because there's no display. And it was getting a bit hairy with all of these use cases being covered kind of by the same thing. So now we more explicitly have an interface, and you construct one of these objects, and you can attach it into your scene if you're using scene, or you can just use it as it is. And this, I do think it's, along with the timers, one of the two things I actually managed to successfully do in summer, which was fun, because the tracing took many weeks out of my project, because I thought it was going to go well, and I really wanted it to happen, but it didn't. So yeah, this is the biggest part. Render timers are cool, but they didn't take very long. This took a lot of thinking, unfortunately. And I do think it's going to make it in. No pressure to maintainers, but it does look quite promising. Yeah. And one day, with the new interface, I did design it, of course, with this in mind. My original goal was to wait after present before rendering. And that is not implemented by the new interface, but it will be pretty simple to add another implementation of the interface on top of these ones that we already have, that will support, compositors saying, okay, the next frame I think is going to take 6 milliseconds to render, so please wait 10 milliseconds before you start it. Compositors will eventually be able to say that into the scheduler, and then the scheduler will do its magic behind the scenes and have a simple interface like the one before, and will allow us to get these latency wins hopefully without too much churn downstream. But it didn't happen in the GSoC period. I'm still trying to keep it going, but unfortunately university exists and I have to go to it. So in the meantime, I've made breaking changes, which is introducing the new interface and removing the old one, but no latency benefits yet, so I'm sorry about that. Enjoy the render timers though, because no downsides there, it's not breaking anything. Thank you to Simon for putting up with me and my horrible webcam. And thank you everyone for coming. I pray you don't have to see me again. Thank you.
Hello. It sounds like we've solved basically very similar problems in GameScope as well. So we also use GPU viz in GameScope. is there a reason you didn't just use the GPU viz tracing header and try and do it yourself?
So I was hoping to, when I say I was hoping to build my own tool, I did notice in GPU viz there was kind of a glaring standing out problem, which was that you can't see events happening live. And I thought that would be really useful. Like I was saying, if you open Firefox and you see things jump up, you can immediately think, okay, that was the problem. So in GPU viz, you have to record a stream and then play it back by loading it up into the visualizer. But I wanted something that would have this continuous view of live frame times. So I was using the Linux tracing shared infrastructure in the hope that someone might load it up in GPU viz and still find these events that I was going to remit useful. But I didn't aim directly for GPU viz in the hopes that I would be able to build a custom thing.
Okay, and second question, does wlroots, does it wait for buffer latching on the CPU or the GPU? Because that might have a big impact on, because you said you were measuring the rendering time, but if you're waiting for buffers to be ready on the GPU, then your render time is basically also completely including all of the client's render time until after it's committed the frame.
So Simon's noticed this and wrote some code. I can't remember if it got merged yet, but not yet. Wrote some code to wait on the CPU. And when I say wait, I don't mean block, but rather if we know that a buffer isn't ready yet, just pretend the client never made the commit, I think is the logic.
Yes.
So yeah, we don't wait on the GPU in the ideal world where all these things have landed. Yeah.
Okay. Oh, sorry. One more. Is there anyone else? Okay. Another question is because wlroots composites a lot of the time, aside from the direct scan-out case, have you ever thought about doing GPU work might cause a clock feedback loop? Because that's one thing that we had with GameScope for a decent amount of time, is that whenever we would composite, sometimes, because we're pretty aggressive to targeting VBlank, that eventually we keep pushing forward and forward and forward because the apps, the rendering time takes less and less, and we push forward enough that the GPU cycles down, and then it takes way longer, and then you get a stutter. Have you ever had any thoughts about trying to address that?
So I've definitely had thoughts. I didn't try to address that because it terrifies me. I don't think I know enough about sort of kernel graphics driver APIs to know if they have any way to say don't increase your clocks because of this job or anything like that. And I feel like clocks are going to change whether I like it or not. So my solution was to just ideally make the tolerance built into the weighting big enough such that if problems start happening where renders take longer than expected because of clocking, then the tolerance catches it and there's no problem. If you have a feedback loop where the clock increases, I genuinely have no idea what I can do about that, unfortunately.
So I don't know if Rob is in the room at the moment, but he was working on some stuff in the kernel with, it was DMA buff deadlines, I think is what it was called. Which is precisely to solve this problem, in particular the problem where you have clock frequencies jumping up and down based off of different stuff. So you might want to consult some of that potentially. I think that's still not upstream yet. Yeah, it's getting the CPU weights involved also kind of makes hash of things, and there's a few other places where it kind of has problems. So point is less that it's solved and more that there are other people working on it and you should talk to them and there is some priority.
Yeah. That's good to hear. I hear there are worries about the CPU weighting thing. I wonder if sort of deadline communication is going to be available to clients as well, like any old app that's rendering. But yeah.
The core DMA fence deadline stuff is wired up in the kernel, and it's wired up for KMS atomic commits. What's missing is exposing it to user space, and that's mainly because we were waiting for a user space to use it.
Right.
So it's in that there's patches that exist. It's kind of in that waiting for an upstream user space use. So yeah, it's sitting there waiting for a compositor to come along.
Right, yeah. So I should have a look at that then. Thank you for pointing that out, because I hadn't heard anything like this. Any more questions? Looks like none. Thank you very much.